Alright guys, and we're back for a second example on this learning target. I'm going to start this video off by telling you guys that I'm really sorry if you hear a little bit of screaming in the background. It's my son. He's upstairs. I've closed the door, but man, that kid is loud. So, we're going to work through this example that we have right here. As you can see, we have fractions now, and it's going to force us to use this step right here. Number 2 in the procedure that I talked about in the first part. If you haven't seen the first part of this two-part series that I'm making right now, go ahead and watch that first, because I go through this procedure and explain where it comes from and how it works. So let's just jump right into this. I have 1/5 times quantity 2x plus 3 plus 1 on the outside here is equal to 1/2 times parentheses 4x minus 1. As you can see, this is a little bit of a beast. I mean, at least it looks like that at the very beginning. But we're just gonna work through our procedural checklist that we have here, and we're gonna start off with number 1. It says if there are parentheses, get rid of them. And I see parentheses. So what I'm gonna go through is I'm gonna use the distributive property and just go ahead and distribute each one of these into these pieces right here, and then as well as right there. A common mistake that I see is that people want to distribute the 1/5 to the plus 1 over here. We're only distributing into inside those parentheses, so there's two terms, so 1/5 gets multiplied to each piece. Same thing with 1/2. Plus 1 is on the outside of those parentheses, so the 1/5 will not distribute to that. 1/5 times 2, well, that's 1 times 2 divided by 5, which is not easily simplified, or it'd be a decimal. We're going to avoid using decimals for now. That's 2/5 x. 1/5, 1 times 3 divided by 5 will be plus 3 over 5. The plus 1 remains the same. 1 times 4 is 4, divided by 2 will be just 2x. That one did simplify down. And then 1/2 times -1 will be minus 1/2. Okay, I think we got rid of all our parentheses. So I'm going to put a little check mark next to that number 1 to signify that I've already used up that step. And then we're going to look at the second step. It says if there are fractions, clear them by multiplying each term by the least common multiple. We have fractions. And I didn't specify that in here. I should probably put that in here. Least common multiple of the denominator. I forgot to put that piece in earlier. So if you were taking notes, write that piece in. The two numbers that I see as denominators here are going to be the 5 here and the 2 here. I do have another 5 over here, but these are the same. So really, I'm just looking for the least common multiple. I'm looking for the least common multiple. I'm trying to find some space to do this. Let's do this right here. Least common multiple of 2 and 5, which is going to be 10. And what I'm going to do is I'm going to use that least common multiple, and I'm going to multiply to every single term that I see here. So I'm going to multiply this by 10, as well as this. And then something that people tend to forget is they forget to multiply it to the terms that aren't fractions. So that plus 1 needs to be multiplied by 10 as well. This 2 is multiplied by 10, as well as this 1/2. And what this is going to do is it's going to make the equation have larger numbers, but they're not going to be fractions, which is going to be convenient for us. 10 times 2 is 20. 20 divided by 5 is just 4. So I got 4x. 10 times 3 is 30. Divided by 5 is 6, so plus 6. 10 times 1 is plus 10. Equals 10 times 2 is 20x. And then 10 times, that was multiplication right there. 10 times 1 divided by 2 minus 5. Okay, so I've cleared all the fractions. I'm done with step 2. I don't have to worry about that anymore. Now what I'm going to do is I'm going to go ahead and look at step 3. It says if there are like terms on the same side of the equal sign, combine them. Well, over here on the left, I do see that I have a positive 6 and a positive 10. On the right hand side, I got 20x and negative 5. Those aren't alike, so there's nothing I need to do there. So I'm just going to rewrite this again. But I'm going to combine 6 and 10 to make 16. Minus 5. Okay. There are no like terms on the left hand side. And there are no like terms on the right hand side. So I'm done with this third step. So now I'm here. I'm going to be working here in this fourth step. And I'm going to use inverse operations to solve this equation. So what I'm going to do is, as I said before in some of my previous videos, I like to keep the term that has the variable in it, the x, I like to keep that as positive. So I'm going to go ahead and I'm going to subtract 4x from each side, which is going to give me a positive 16x on this right hand side. If I were to subtract 20x, it wouldn't be wrong. It would just give me a negative 16x on this side, and I don't like dealing with that negative. Sometimes it gets lost in some of the work that we do. So again, I just keep it positive. This is 0. I rewrite this as 16 equals, this is 16x minus 5. Alright, so now I'm going to go ahead and I'm going to add 5 to this side. Add 5 to this side. Remember, I'm trying to get x all by itself on one side of the equal sign. Just so that I can figure out what the value of x is. I can see what the value of x is at that point. Negative 5 and 5, those are going to zero out. That's 0. 16 and 5 make 21 equals 16x. And I'm almost done. I'm multiplying x by 16, so I'm just going to go ahead and use the inverse operation, which is going to be divide by 16. And something that you're going to notice when you're working with equations is that not just because you don't get a whole number answer doesn't mean the answer is incorrect. I think as math teachers and instructors, we tend to give students equations that have whole number answers or integer solutions because it's easier and we don't have to deal with the fractions when we're doing it with the solution check. But at the same time, when students solve an equation that doesn't have an integer solution and they get some sort of fraction, it kind of freaks them out and makes them think that they didn't do the problem correctly, which they may have done so. In this case, we ended up with a fraction. I don't think we can reduce that, so I'm just going to leave it as 21 over 16. Now, we're done. The only thing we don't know is whether our answer is correct or not. So, if you saw the previous video, we actually we do what's called a solution check. So solution check, and we've taught most of you guys, all of you guys, to use a calculator to do this to help yourself out. I'm gonna go back and plug in 21 over 6 in for x. Every single x that I see here is gonna get plugged in for that into the original equation. So I have 1/5 times 2, and then I'm going to open up another set of parentheses. I'm going to plug in 21 over 6, and I think it was plus 3. And is that equal to, oh, I may have missed a 1. I missed the 1. Plus 1. Is that equal to, that's what that question mark is saying. We don't know if it is or isn't yet. 1/2 times 4, and then there's an x there, so I'm going to write 21 over 6 minus 1. And I know I did that kind of quick and I was scrolling up and down. Remember, you can always pause the video and then go back and check to see what I did or figure out what step I actually took. Okay, so let's move on. So I am not going to I'm not going to distribute here. I'm not going to do anything like that. All I'm going to do is I'm going to take everything that I plugged there on the left and I'm going to type it into my calculator. Sometimes when you type stuff into your calculator, ooh, and I forgot something here, didn't I? This should be 16. Ooh, I'm glad I caught that. Sometimes when you type it in the calculator, you have to be careful about making sure that you add in parentheses where you need parentheses. In this case, if you're using like a TI-83, it makes it easier. Some of the other ones, like the little blue calculators that we use that are a little bit more simple, are a little bit more difficult. But just write it down, and then just put the parentheses where you need to put parentheses and do it that way. If I plug in this left-hand side into my calculator, I end up with 2.125. And I know I said don't use decimals. In this case, it's okay. We're just checking the answer. Checking to see if your answer is correct. If I plug in the right-hand side, I got 1 divided by 2. Let's see, 1 divided by 2 times 4 parentheses, 21 divided by 16. And remember, if I get the same thing on the right-hand side and as on the left-hand side, then my solution is correct. And I got 2.125, which means those two things are in fact equal, which means that this answer right here is correct.